Let's start doing some physics. This is Unit 3, Lesson 1. What happened to Unit 2, Mr. Dueck? I had to toss it. When we brought in flex, something had to go. I used to do a unit, so we're going to be looking at kinematics, which is the fancy word for the study of how things move. We're going to look at it mathematically. I used to start out by doing it graphically with graphs, and it was visual, and it was nice in some ways, but there's a real limitation with graphs. First of all, they're a pain to draw. It's a pain to do a graph for every question. I kind of like to reach the point where I can just go to my calculator and get the answer and walk away and drop the mic, and that'd be much nicer. And so I moved away from that. Something had to go. In physics, my angels, every measured quantity is one of two things. It is either a scalar or a vector. Anytime I introduce a new concept to you, first, I will tell you what the symbol will be, because we're going to abbreviate. Usually it will be a letter. Sometimes it'll be a Greek letter. Then I'll tell you what the units for it are. But then I will always tell you whether it's a scalar or a vector, because scalars and vectors behave differently. Now, it won't make as big a difference in Physics 11, because in Physics 11, we're going to stay mostly one-dimensional. But in Physics 12, we'll get two-dimensional. Scalars, you're going to need to memorize whether it's a scalar or whether it's a vector, but I wouldn't freak out. You're not going to have to make, Marcella, flashcards or anything like that. I'll repeat it so often that you will just pick up on it. Scalars have magnitude only. Magnitude is a fancy word for size. Then it says, for example, I'm going to give you some examples in a second, but I'm also going to tell you what a vector is. Vectors have both magnitude and direction. So vectors have both magnitude and direction. Scalars have magnitude only. They have no direction, much like your futures. So let's look at some examples here. An example of a scalar. Time is a scalar. How much time did it take? 31 seconds. It doesn't make sense to say it took 31 seconds north. Time has no direction. Mass is a scalar. Speed is a scalar. Distance is a scalar. This is going to all seem really intimidating. Relax. You'll end up memorizing this just without trying, because I'll be flogging it to death. Voltage is a scalar, volume is a scalar, area is a scalar. Don't write all those down. Those are the 3 or the 4 that you'll run into the most this year. Thank you. Vectors, stuff where direction matters. Velocity. How is velocity different from speed, Mr. Dueck? I'll show you in an example in just a second, Noah. Displacement. Acceleration is a vector. If you're accelerating forwards, you're probably speeding up. If you're accelerating backwards, you're probably slowing. Oh yeah, it makes it there. Definitely has a directional component, because a different direction changes the whole situation. Force is a vector. The direction that you push on something changes. It definitely matters. If you push on something forwards, it'll move forwards. If you push on something in the opposite direction, it'll move in the opposite direction. Electric field is a vector. Magnetic field is a vector. Current is. There's all sorts of other things. Momentum is a vector. Don't worry about memorizing an exhaustive list right now. We're going to do a little chart here. In particular, I want to talk about some of the ones that are paired together. Speed is a scalar. As an example, 30 meters per second. That's a speed. You're writing this down, right? You weren't looking at your phone or anything foolish, no? No. Okay. You're back. Full disclosure, by the way, and I may have said this, but I'll repeat myself. I may have said this, but I'll repeat myself. I may have said this, but I'll repeat myself. See, I did that. If I sense you're zoning out, I'm calling on you. And anytime we're doing calculator work, if I say, so what's the answer? And you haven't picked up your calculator, you're the one I'm going to ask to tell us the answer. I will, right away, you'll see me scanning. I'm looking to see who isn't on their calculator. I'm coming for you. So make sure you participate. And it's also just an easy way to participate. And to be honest, there is a tiny motivation, little nerdy adrenaline rush when you type it in. I got the right answer as my neighbor. Yay! So follow along that way. Thank you for getting your calculator out and picking up on my hint there. Velocity is a vector. Thank you. I know my audience. You want an example of a velocity? 30 meters per second south. Time is a scalar. I already said that. We're going to abbreviate. We're going to use symbols or letters as abbreviations. What would be a good letter to use for the word time? We're going to use a lowercase t for the rest of the year. If you ever see a lowercase t sitting by itself, I'm telling you that's time. Any time you see, I missed that joke. How did I miss that? Any time you see a lowercase t by itself, it's time. Wow, I'll have to add that to my repertoire. That was just staring me in the face. So, 15 seconds. Acceleration is a vector. I'm going to abbreviate acceleration with Actually, no. What would be a good letter to use as an abbreviation for acceleration? Lowercase a. Pardon me? Nope. It all depends. In the same way, m equals, that's mass, equals 5m, that's meters. So equals 5a, that's years. A equals, that's acceleration. I think I've already said to you, we got 26 letters. We could have used more. We're going to run out. We're even occasionally going to bring in some Greek letters. We're still going to run out, but that's okay. I've never had a kid by the end of the year say, I don't remember what stuff means. We're going to flog it to death so much. It's not like you have to build flashcards or anything for that. Distance, 19 meters. Displacement, negative 19 meters. I would read that as I ended up 19 meters behind where I started from. In Physics 12, because we're often going two-dimensional, Petco, we tend to use south and north. We do compass directions. In fact, in physics, if you talk to my Physics 12s right now, they're learning vector mathematics. If you talk to anybody in my grade 12 class and you say to them, how do you add vectors together? They'll say, oh, you add them tip to tail. There's a whole new branch of mathematics called vector mathematics. In Physics 11, we're going to keep everything in a nice straight line. And so typically, if we want to show that something is moving forwards, we'll call it positive. If we want to show that something is moving backwards, we'll call it negative. If you want to show something is moving up, we'll call it positive. If we want to show something is going down, we'll call it. Those will be our big ones. Now, we won't stick with that always. As we get good, after Christmas in particular, what we'll say is we'll let positive be the direction that makes the math easier. It may make the math easier to let down be positive, so we'll just do that, because there's no rule that says down has to be positive. But for the most part, you want me to show me something's going backwards? Call it negative. Or to the right is positive, to the left is negative. Mr. Dueck, yeah. I wish there was a dumb way that I could remember that speed is a scalar. Mr. Dueck, if you were a good teacher, you'd have an easy, dumb way for me to remember that speed is a scalar and that velocity is a vector. Mr. Dueck, do you have an easy way that I can remember that velocity is a vector and speed is a scalar? I'm a terrible teacher. I got nothing. You'll have to come up with something on your own. You picked up on the hint there? Unfortunately, the tricky one where I have nothing is distance and displacement, because they both begin with a D. Oh, even worse, they both begin with a DI. Oh, even worse, they both begin with a D and an I and an S. You're going to have to memorize that distance is the scalar and that displacement is the vector. And if you come up with a dumb, stupid way that works for you, tell me, and if it's good, I will use it for the rest of my teaching and give you credit. I have tried everything. I thought, well, distance is a shorter word than displacement, so maybe scalar has less letters than, oh no, 6 letters each. That didn't work. Distance has an S in it, S for scalar. Displacement has an S. Yeah! If you come up with something that works for you and it's dumb and easy to remember along the lines of scalar, speed, vector, velocity, let me know. I'll take it. I could fill in more, but don't worry about it. In a textbook, to show something as a vector, we would write it with a bold font. So, for example, the symbol for velocity, what would be a good letter to use for velocity? Lowercase v. Uppercase v, you might recall from Science 9, was volts. We're going to have to distinguish between uppercase and lowercase because we only got 26 letters. A textbook, if it wanted to show velocity, don't write this down, would bold font it. But that's a stupid thing to try and handwrite. So we have a vector symbol. This you can write down. We use a V and we put an arrow over it to show that it has direction, except we're lazy. Percy, we only put half the arrow, the top half. We don't even bother filling in the entire head of the arrow. You can if you want to. I won't take marks off. But here's where it's going to get a little bit tricky. Everybody look up, please. That's velocity. Look up. That's speed. Why don't we use S for speed? S is taken by something else, and velocity and speed are closely related. Speed is the scalar version of velocity. Speed, velocity, speed, velocity, speed, velocity. I will not, Carter, take marks off if you use vector signs incorrectly. They'll naturally take them off because often it will mean that you forgot that something was a vector and are treating it like it was a scalar, or you forgot that something was a scalar and you're treating it like it was a vector. And the rules for vector math and scalar math are different. Really different in Physics 12, a little bit different in Physics 11. Let's talk about distance versus displacement. Distance versus displacement. Distance is how far an object has traveled. What's the distance between Vancouver and Pitt Meadows? About 45, 50 kilometers, maybe more, I don't know. What's the symbol for distance? Isaac Newton used a lowercase s. We're not going to use that, so you can cross it out if you wrote it down. Lowercase s is taken by something else now, and it also is the unit for seconds, and it looks too much like a 5. The correct symbol for distance, if you take a university physics course, the correct symbol for distance that they'll use is a lowercase x, because they want you to imagine you're on the x-axis of a graph, moving to the right, moving to the left, and so they want you to use an x. We're not going to use that, even though it's the correct symbol, so you can cross out the x. Oh, how does that cross out the x? Okay, cross, yeah, whatever. That was a joke. It's tough to cross out an x because you... Nothing? Okay. It's good material, David. You know what letter I'm going to use for distance? I'm going to use lowercase d. Right now, a physics prof would be screaming at me and saying, hey, Kelvin, that's wrong. It is, but it's easier. I'm going to gamble that if you take post-secondary physics, you can make the shift, but I'd rather make it a little simpler in Physics 11 when we're throwing all this new stuff at you. It's wrong because also if you take calculus next year, a lowercase d means something hugely important in calculus. But you know what, Alyssa? I'm going to gamble if you're taking calculus, you're clever enough that you can keep them straight anyways. So what are the units for distance? Does anybody remember what our fundamental SI unit for length or distance is? Meters. Like I told you, anytime I introduce something new to you, I'm going to give you the symbol, the units, and then I'll tell you whether it's a scalar or a vector. Scalar. Displacement is a little bit different than distance. It is the object's change in position. Symbol should be an S with a vector sign. That's what, no. Should be an X with a vector sign. That is the correct symbol. I'm not going to use that. I'm going to use the letter D with a vector sign because displacement. Units, also meters. It's a vector. Right now, that doesn't explain the difference between distance and displacement. My apologies to those of you who are on YouTube because you can't see this. I'll try and talk really loud so you can still hear it because I'm standing up moving away from my laptop. The rest of us in the class, we're going to count together. I'm going to show you the difference between distance and displacement. Let's pretend I'm standing at 0. I'm facing this way. And let's pretend, just to make the math easy, that each step I take is exactly 1 meter long. Count with me. 1, 2, 3. What's my distance? Give me the obvious answer, please. 3 meters. What would my displacement be? You could say 3 meters right. Oh, but that works for you. But for you, I'm not. You know what? Positive 3 would be a good way to describe it. That should work for any orientation on the paper. Okay? Back to 0, 0, 0. Count with me. 1, 2, 3, 4. What distance did I travel? How many steps did I take? How many meters did I walk? What distance, how many steps did I take? How many? 4. My distance is 4. But what's my displacement? What's my change in position? Not 4. Positive 2. Or 2 right. Well, no, that doesn't work. Positive 2. Okay, back to here. Count with me. 1, 2, 3, 4. What distance did I travel? 4. What's my displacement? 0. When you're giving 0 as an answer, it doesn't have a direction. There's no way to say, positive 0, negative. 0 is just 0. So if you're giving me a vector answer of 0 and you don't include a direction, I won't freak out. So we'll typically use positives and negatives to show directions. It's an easy shorthand, pretty obvious. And the difference between distance and displacement. Distance is how many steps you took. Displacement doesn't care how many steps you took. It wants to know where'd you start, where'd you end up. That's your change in position. That's your displacement. Okay. By the way, when you go for a walk, for exercise, I did a 5K walk. That's your distance, but every walk that I've ever seen, the people end up back where they started from. Your displacement, whenever you go for an exercise walk or go for a run around the track, is always 0, because you didn't change your position. Okay? That's going to seem very, very, it's going to get easier, because in fact, when we start actually doing physics questions, we'll be able to be a little more casual because the directions and the numbers will be much more obvious than some idiot walking in a classroom and everybody counting their steps. Okay. When objects start moving, it's useful to be able to describe an object's location. To describe location, we imagine a little meter stick or a number line. Objects to the right we typically call positive. Objects to the left we typically call negative. That's not a rule. You could flip-flop it, but let's decide that typically we'll let right be positive and left be negative, just so all of our pictures look the same. A bug walks along a number line. It starts at A, and it walks to location B. Then it turns around, and it goes from location B to location C. Callum, see the 2 little walks? What distance did the bug walk? Well, first of all, let's look at the yellow line. How long, Callum, is the yellow line? How long, Callum, is the green line? Look carefully, please. It starts at 4 and it ends up at -6. How long is the green line? How long was the yellow line? How long is the green line? What's the total distance the bug walked? Not 10, which somebody blurted out earlier, but 14. D for distance, no vector symbol. 14 units. It says meters. By the way, this is terribly inefficient. Eventually we'll have equations where we'll just calculate the distance. Give me enough information, I can tell you how far on my calculator without having to, whoa, different paths and count. But, okay. What's the object's displacement? What's the bug's displacement or its change in position? Where did it start?
6.
It's not 6. Where did it start? 0. Where did it end up? Careful, please. So what's its displacement? Not 6. You could either, don't write this down, you could say 6 meters left, but what's a shorter, better way to write left? What did we just decide? So you can write this down, that. Or you can write 6 meters left. I'll give you full credit for that. Don't do this before you turn the page. Don't do this, because if you say both of them, negative left, I would argue that negative left is right. Right? Right? I think negative left is right, because negative is opposite. So what's the opposite of left? Right. Right?
So when you're talking like displacement of an engine, technically it shouldn't be
That's a completely different concept. Displacement in an engine. So we also are running out of science words. In an engine, the displacement is talking about how the volume of air that it's moving out of the pistons, and that's a completely different concept.
But if it were, it would be like a negative 6 liter engine, right?
I can't answer that question the way you're asking, and you don't know why yet, but volume is a scalar, and so any answers that I should be giving you should be phrased as positive numbers, but then next to that positive number, I would either add the word gain or loss, because those are magnitudes, not directions. You see, I really have to be fussy. It's a great question. You're the first kid in 10 years to clue in, oh yeah, displacement also shows up in engines. I have to answer that very carefully because that's a completely different type of displacement. Great question, though. By the way, I love nerd tangent questions like that. So if you have something, always you can feel free to ask. Sometimes I'll say, because I've done this before, I'm going to answer that in about 30 seconds because often I built the lesson up to have that question percolate up in your brain. But I love it when you ask. Next page. Oh, turn the page, I think, isn't it? If you haven't already. Little thought puzzle for you then. It says this. Suppose you run along 3 different paths from location A to location B. Along which path would your distance magnitude be different from your displacement magnitude? I'm going to give you a hint. I'm going to reverse the question. Only one of these paths has the same distance and displacement magnitude. Which one? Carter, did you say it or not? Oh, sorry. Path 2, because your distance would be that and your displacement would be that. So that's not what the question is asking. The question is asking which ones are different. So not path 2, but path. Those have different distances and displacement. The distance would be following the line. The displacement would be the straight shortest distance between the 2 points. Yeah.
The displacement's the same on all 3.
Yep. By the way, we're going to move so far beyond this that this really isn't hugely crucial stuff to wrap your brain around, but I'm planting the seeds for some terminology when we start doing this all mathematically. We can also talk about position. We can give positions as positive or negative. So here's a number line. What's the position of the heart on the number line? You could say 4 meters to the right. But Aiden, when you're done yawning, what's a shorter way to say 4 meters to the right? Are you positive? Now, if you just wrote 4 meters, I will clue in that that number is positive. This is one of the few times where I write extra. I do put the positive in because I'm reminding myself I checked the direction. But I would give you full credit if you just said full meters, 4 meters. Yeah, that is positive. But I love the way that you said, oh, it's a positive direction, check mark. How far? 4 meters. What's the position of the diamond? Yep, or 4 meters to the left, but that's shorter. What's the position of the cross? 0 meters, and now you're seeing what I meant when I said 0 doesn't really have a directional component, it's just 0. That's locations or positions. What if we want to somehow show motion or movement? We can use an arrow to represent a specific displacement. Yes?
If you want to put the units for 0, would that still be right?
I'm a little less fussy if you don't put the units next to the 0, because one could argue that this is saying nothing, no units. Well, but this is not multiplying. I got to also say we're not saying this is 4 times m. We're saying this is adding up 4 consecutive meters in a row. I won't be that fussy on it. Yes, you're correct. Although a good habit is anytime you're writing something down, put the units. I don't know if it was in this class, but in one of my other classes on the test, one student got 25.5 out of 26 because on the very, very last question, the one where I had you build a big chain, they didn't put units on their final answer. And you know I'm rubbing that in when I hand the test back to them. If I was clever, I would have showed you a Verizon phone call about some poor frustrated man trying to explain that units matter. I did? Oh, good. We can use arrows to represent a displacement, a direction. Here's a bike moving along a number line from a position of +4 to -3. We're going to often be using words like final and initial, but we're going to abbreviate. What would be a good abbreviation for the word final? We're going to use a lowercase f as a subscript. What would be a good abbreviation for the word initial? We're going to use a lowercase I. In other words, if I didn't want to write the word final, I might use, for example, an X for position and a lowercase f, and an X for position and a lowercase I. One of the things that I will always do for those of you in the back corner, Aiden and Percy, is if it's a 1, I'll do that. If it's an I, I'll always put a little tail on it, so even if you can't see the dot on the I from way back there, if it's got that little taily thing, that's the lowercase I letter. That is not a number 1 letter, because sometimes we will use a subscript of 1 to say that's the first object, and then x2 is the second object. So just, you don't have to do it that way. Something I came up with so kids can read better. Callum? Pardon me? Oh, I told you that already. Always cursive. I did that when we did leaders. Always. Okay? You'll even find I've picked fonts that have a cursive L. If I'm ever having to use that, if I'm typing something, I'll go find a font that does it cursively, not lower. If it's by itself. If it's part of a word, it's pretty obvious, right? So we're often going to use a variable, x or d, to symbolize an object. I could also have used the letter d for the final displacement and the letter d for the initial displacement. I used x just because I noticed it said an x down here. And we'll use subscripts, I or f, to show initial and final. That subscript notation we'll do fairly often. In fact, if you look at your formula sheet, you'll see a lot of the formulas have little subscripts in them. It's a shorthand way to write stuff. Example 4 says, draw an arrow showing an object that moves from the -4 meter position to the +5 meter position. I can do that. I'm going to put a little dot at -4. I used the letter X last time. Just for a change, I'll use the letter D. And this is my initial position, so DI. There's my final position, DF. And to show the direction of movement, I'll draw a vector arrow. You might recall from the Despicable Me video, vectors are represented by arrows showing magnitude and direction. Again, in Physics 11, we won't need to be quite this fussy. We'll typically be pretty casual, Noah, and say, oh, positive is forwards and negative is backwards. In Physics 12, if you ask my students right now, we've been adding arrows all over the place. We've been adding, for example, how do you add an arrow like that to an arrow like that? There are mathematical rules to do it. How do you add north plus west? There's absolutely a way to do that as well to get the final direction. But that's Physics 12, preview of coming attractions. Gonna make it? Good yawn? Okay, I'm coming at you soon, so be awake. Hey, Melissa, what's this object's distance? How far did it travel from there to there?
9.
Yeah. 9? Yeah. 9. I gotta be fussy. Just 9. She said positive 9. That would be a directional. I would live with it if you said the displacement was positive 9 meters. The distance, even if the arrow was pointing in the opposite direction, I would still say the distance was 9 because distance is a scalar. It has no direction. Much like your futures. Yeah. Is that okay? Let's compare that with example 5. It says, draw an arrow showing an object that moves from the 7 meter position to the 1 meter position. So now we're starting here, and we're ending here. By the way, I should have up here, I should have put a vector symbol on both of those D's because there is an arrow. These are technically displacements, your final displacement and your initial displacement, because there is a directional component in the picture. Arrow. Cleo, what's this object's distance? How far did it travel from here to there? Careful. Thank you. By the way, don't make sloppy mistakes like that, because that's throwing away marks, right? 6 meters, I agree. Mr. Dueck, you said how far did it travel from here to here, but it traveled in the opposite direction. I don't care. I was doing distance. There's no direction. It's a scalar. I didn't care at all. But now, what's this object's displacement? Not positive 6, but yes. Or you could say 6 meters to the left. Easier to write that. Now we're going to talk about speed versus velocity. Which one is a scalar? Which one's a vector? Okay. It's not, that distinction isn't going to become important for a while until we get into more complicated questions, but it will become important in about 3 lessons. Average speed is defined as triangle D over triangle T. Except we don't say triangle, we say delta. Except we don't even say that. What's a delta an abbreviation for? Which 2 words in English? You got your formula sheet? Look in the top right corner of the front page. What's a triangle an abbreviation for? Okay, it's the same. I will read that as the change in distance over the change in time. But how do I calculate the change in? What's change in anything? You just read it to me. What's change in anything? How do I calculate change in? Final minus initial. It's on your sheet. You'll probably end up memorizing it sometime after Christmas. We do a unit on momentum. We calculate something called impulse, which is the change in momentum, which is the final momentum minus the initial momentum. And I flog it so much during that unit that most of my kids, whenever I say, what's change in anything? Final minus initial, Mr. Dueck. My Physics 12s certainly have memorized this without trying to. So if I want to generate an equation, speed, lowercase v without a vector, to show average speed, I'm going to write a subscript average. I don't know. And that's going to be the final distance minus the initial distance. Once you've written that down, look up, but don't write this next bit. Change in time should be t final minus t initial. But we're lazy in physics because time is always a change in. The only way to measure time is to start and stop a stopwatch and subtract the 2 totals. We get so lazy, we stop putting the final minus initial. In fact, we even stop putting the delta, and we just say it's time. you'll find there's one other variable we do that for in physics 12, and it's voltage. Voltage is always a change, and it's always a comparison between the voltage in two locations, and so we get lazy and stop putting the delta. What would the units be? Well, first thing I notice is a fraction bar, so I'll draw that in. Nick, what are the units on top? What do I measure distance in? What do I measure? What units? There we go. What? You mean the equation actually tells me the units? Yeah. Scalar or vector? Speed? Yeah. You've picked up probably that I have a dislike for memorizing stuff. It is worth memorizing what units go with what concepts. In physics, we're going to be doing word problems all the time. Not the stupid word problems that you have in math that make you scared because they're written so poorly, and they are, and which are boring because they are. We're just going to be giving you application problems, and you're going to find what I do to solve a physics application problem is I look for units, and if I see a meters per second, I know it's a speed. Even if they didn't call it a speed, that number is a speed. So as someone who hates memorizing, if I tell you that it's worth memorizing units, it's really worth memorizing the units. Sorry for those of you on YouTube. Turn the page if you didn't already. Average velocity is going to be the change in the displacement over the change in time. It looks almost exactly like the same equation. No, I put a vector sign. Yeah. Where change in anything is going to be, where delta is going to be change in, and Owen, what's change in anything?
Final.
So if I want to find average velocity, that's going to be the final displacement minus the initial displacement. If we're starting from 0, it's just going to be the final displacement. Technically over time final minus time initial, but time is always a change, and so ridiculous. What would the units for this be? Also, can you see it? Meters per second is the vector. We're going to finish this page, and this is where we're going to pause, and then I'll come around and let you know how you did on your quest. So, if the bugs trip mentioned in example 1, remember the bug? Mentioned in example 1 took 30 seconds. What was the bug's average speed? Well, speed is going to be the change in the distance over time. How far did the bug travel, Callum? Do you remember? I think you were the one that I picked on for this. Sorry? I think you're right, but I can't hear you. Yes. How much time did it take according to this question? How do you know that's time? It never said the word time. This is why it's worth memorizing what units go with what concepts. In fact, eventually you would have, when you're good, you would have right away, as soon as you saw that, just made a little note, oh, t is 30, and I don't have to remember that anymore. I've got it written down. It's going to be 14 divided by 30, which is what? This is where you're going to get your calculator out, because this is where I'm staring at you to see if you're typing it in. By the way, that 14, how many sig figs? That 14, how many sig figs? 2. That 30, how many sig figs? Not 2. So technically, how many sig figs should I go to in my answer technically? Forget that. We're going to ignore sig figs for the rest of the year, but I'll review it the way I just did. Let's go to 3. So give it to me to 3 sig figs. I'll give you a hint. There's going to be a 4. There's going to be a 6. I need one more digit. Sorry? 7 or 6? You round properly, which in this case is round up. Units? Units? Meters per second. Direction is none. Trick question. This is speed. How fast was this bug traveling? Little less than half a meter per second. 0.467 meters per second. Now let's compare that with its average velocity. Average velocity is going to be the change in displacement over time. What was the displacement of that bug? Do you remember? If you're not sure, go look. -6 over 30. You're going to get a negative answer. 0.2, I think, if I do the math in my head. Double check me, but I'm pretty sure. Mr. Dueck, do you want 0.2 or 0.2? I don't care. I'll put 0.2. I'll stop there. I'm not going to go to 3 sig figs because it just happened to work out cleanly. What is the negative telling me? It's telling me that on average, this bug was traveling backwards for longer than it was traveling forwards. Well, of course it was, because it ended up behind from where it started. It must have been traveling backwards for longer than it was traveling forwards. Its average velocity was negative 0.2 units meters per second. Yep. Yep, I know.
As far as time goes, it could have been going backwards.
Time's a scalar.
Yeah. If it were moving backwards, it could have been moving less time backwards if it were going faster than it was going backwards.
That's why this is an average velocity. We can't yet deal with acceleration. Patience, young grasshopper. We'll get there, I think, less than 3 or less than 4. Right now, all I can have you do is drive in a car, keeping your foot steady on the gas pedal. No brake, no speeding up. We'll get there. But actually, it turns out just with these concepts, we can do some interesting stuff, you'll see. So the equation that I've given you is this one, V average equals D over T. I dropped the change in front of the D because I'm lazy for now. How many variables are there in that equation? How many letters are there in that equation? That 3, V, a D, and a T. Don't worry about the subscripts. Those aren't variables. So a V, a D, and a T. There are 3 variables. What that means is it's actually 3 equations, not 1. You can memorize all 3 equations, or this is where I'm going to start to teach you to derive equations in your head. Some of you may have been given by your science teacher that stupid thing. I hate it. It's a crutch, and it's very limited. It only works for a 3-variable equation. Most of our equations will have 4 or 5. It only works for equations that look a certain way. I don't want to have to make all of our equations look the certain way. I'm going to teach you how to use Math 8 and Math 9 to rewrite any equation in your head, and it starts now. If V equals D over T, what would an equation be for displacement and for time? Well, since it wants me to find 2 things, I'll do that. Cleo, my friend, we're going to do the displacement equation first. What letter means displacement in that equation? Yeah. What letter in this equation? Yeah, and I meant that to be good. I love the way, oh, good, D, yes. Okay. What side is the D on? The left side of the equation or the right side of the equation? So I'm going to get the D by itself. What side is the D on? Say it again. The whole left side is just going to drop down like a domino. Do that. I know that. Whatever side it's not on just drops down. Kathunk. That's my first step when I'm doing this in my head. We'll do this writing out for a while, and then we'll start to do it in our head. Back to the right-hand side. See where the D is, see where the D is, see where the D is. What other letter is on the same side as the D? Where is that T, on the top or on the bottom? That means it's dividing. Dividing on the right-hand side with a T is the same as doing what on the left-hand side? How could I move the T over to the other side? Owen. So you're saying I could multiply the T over to that side? Yes. And then look up, look up, look up. Don't write this down. Look up, look up, look up. Don't write this down. In my mind, I would imagine that, because, don't write this down, we've got the D by itself. You took care of the T by multiplying it over, but I'm not going to write that. This says V times T equals D. Do you mind? Instead, I'm going to put the D equals on that side because that's where we're used to seeing the thing that's by itself. There's a new equation. Write that down. Oh, and this is the vector one, so I'll put displacement and velocity. It works for both. Yep. Next time you can just quietly sneak through and get there. Yeah. Yeah, it's the good electric one. I'll talk loud. I think I gave you this one on your formula sheet, second or third line, maybe? I think I gave you this one on your formula sheet. I shouldn't have. I only should have given you one because I hate giving you more than one of the same equation. Instead, I'm going to teach you to rewrite these. Cole, what's the second thing it wants me to get by itself? What letter is time? Where is the t in this equation? Oh, I just erased something accidentally. Where is the t in this equation right here? On the?
Right side,
But specifically on the right side where? On the?
bottom.
Ah! Yuck. Wait. You awake now? Where is the t in this equation? On the top? On the right side? On the top? This will be way easier to work with. What side is the t on? The right side?
Right top.
What's going to drop down like a domino?
And
That. Write that down. Next to the t, there is a v. What's the v doing to the t? Adding, subtracting, multiplying, or dividing? How will I move it over?
Divide.
Oh, it's an av. It's got a vector sign. That equals t, but do you mind, instead of writing equals t, I'm going to put the t equals on this side because that's where we prefer to say things. You're going to be amazed, but in about 2 weeks, almost all of you will be doing far more complicated ones than this in your head. And if you can get there, I will allow you to absolutely not bother showing any work, to go straight to the correct equation, to go straight to the plug and chug and go to the answer. Because that's what to me, that's becoming an expert. If you can do it showing minimal work, that's becoming an expert, and I will push you to get there. On a test, I'll always show extra work to avoid making a silly mistake. But if you can get to the point where in your homework you can do it in one line, I'm not going to punish you for that. I think I'm going to say, good. We're going to finish with example 7. A motorist, this is your first physics word problem. I have 2 big approaches that I give students, hooks, tools, tricks of the trade when you're dealing with a physics question, that when you don't know what to do. Don't write this down. The first is this acronym here. My physics 12s all know this. DULP. It stands for draw a little picture. Mr. Dueck, I'm stuck on number 7. Have you DULPed? I'll say to my physics 12s, no. Well, then I won't help you. Not until you draw a little picture. The second acronym that I use is a problem-solving approach that I call DFIC. Don't write that down. We'll put it in our notes later. The DFIC, the D stands for list your data. The F stands for find a formula. The I stands for insert the numbers. And C stands for calculate the answer. So I'm going to model that almost all the time. Now, eventually you'll get good enough that you can take shortcuts with that, Austin. I'm good with that. But for now, Austin, my friend, what's this question asking me to find? Read the question to yourself carefully, all of you. And the first thing you're always going to ask is, what's this question asking us to find? What is it asking us to find? And you notice that's way easier than the stupid math word problems you get in your math books. Like, it's pretty obvious. It will always be something like find the, or what is the. Say it again, loud and proud. Good. There's a part A, so I'm going to write down a part A because I've written something down. And I want to write down the following. They want me to find the average speed, but that's way too much writing. So here's what I'm going to write down. V av equals question mark. I almost always write that down because, first of all, Nick, I've written something down. I'm more relaxed. It reminds me what I'm looking for. Now, Austin, we're going to go through the question looking for numbers. What's the first number you see? What are the units next to it? So what is that 350? Time? No. Yep. Did they say the word distance in the question anywhere? But the units told you? Oh, cool. So I'm going to go D equals 350 kilometers. Keep reading. What's the next number you see, Austin? What are the units next to it? So? It's got to be. Did they say the word time? No. And then I would say to myself, I'm looking for an equation that has a v, a d, and a t in it. Now, right now, you only really have one equation, sort of three equations, but one equation. By the end of the year, when you've done the whole formula sheet, this will be what you're doing. So we're looking for an equation that has a d, a v, and a t in it. There is one. It's this one here. But you know what? Let's use the one that has the v by itself, this one here. You okay with that? So it's going to be v equals d over t. What's d in this question? What's t in this question? By the way, what are the units for the distance in this question? What are the units for time? This is actually going to give us, can you see it? Kilometers per hour, which is what they wanted. I'm not going to bother converting this stuff. I'm going to leave it in kilometers per hour. The equation will still work. What do you get? Is it 58.3 repeating? Is that what you got? You typed it in already? Okay, I didn't see you type. I was going to come at you, Davis, but I think you look like you know what you're doing. All of you want that on your calculator because, trust me, we're going to use it in a second. Noah, what's B want me to find? It wants me to do a unit conversion. Hey, we just wrote a quest that had unit conversions on it. What was the first thing that I always did whenever they wanted me to convert something? What was that, Carter? I wrote down what they gave me. Oh, Noah, you let me down. Oh, but you'll notice I wrote this as a nice two-level fraction. I've been writing the units kind of as slanty fractions, but now that I'm doing unit conversions again, okay. Noah, I need to get rid of kilometers and I need to get rid of hours. Which one pick first? Doesn't matter. Okay, where is kilometers going to go in my next fraction? What's going to go on the top? Kilo is 10 to the 10 to the? Oh, I didn't hear you say, I heard someone here, but 10 to the 3. And common mistake, this is probably the most common mistake on the quest. Where does the 10 to the 3 go? Where the kilo isn't, which in this case is on the top. That gets rid of kilometers. Now I got to get rid of hours. Where is hours going to go? Do you remember how many seconds are in 1 hour? Anyone? Don't go to your calculators yet. Stop. We're gonna do this one so often. We're gonna add a shortcut to our formula sheet. It turns out, if you times by 1,000 and divide by 3,600, same as just dividing by 3.6. And we're going to do this conversion from kilometers per hour to meters per second fairly often, or going from meters per second to kilometers per hour, because cars. So you got your formula sheet handy? On the front page of your formula sheet, on the bottom, you're going to write something. Don't write anything yet. Here's what I'm going to write. I'm going to write kilometers per hour. I'm going to leave a space. I'm going to write meters per second. I'm going to draw an arrow pointing that way, and I'm going to go divide by 3.6. I'm going to draw an arrow pointing this way, and I'm going to go times by 3.6. You can write whatever you want that's short and succinct, kind of like that. You can write exactly that if you want to. I think that's enough to let you know, oh, if I want to go from kilometers per hour to meters per second, the shortcut is divide by 3.6. If I want to go from meters per second to kilometers per hour, the shortcut is times by 3.6. On the bottom of your front page of your formula sheet, write something. I don't care how you make that note. Most of you, believe it or not, will end up memorizing that by Christmas because you get sick of looking it up on your formula sheet, which again is the only reason you shouldn't have to memorize useless stuff. But we'll stick it there anyways. And then once you've done that, if you divide by 3.6, what's the correct answer? 16 point. Let's go to 3 sig figs. 0.2, I believe. And by the way, it isn't 16.19. Not if you used your answer button, which you should have because you had this sitting in your calculator already. You shouldn't have needed to type 16.2, not 19. If you used 58.3 and retyped it, why would you type a rounded off answer when you have an accurate answer button stored on your calculator? You did more work for less accuracy, I say. What was your question there? Bottom row? Okay. Because I'll look at yours in a second. Pause.